Here in video 4 of this 4-part series of voting apportionment methods, we're looking at Huntington-Hill method, which starts out pretty similar to Jefferson's method that I covered in video 2. I'll duplicate this sheet from Jefferson's method and use that as my starting off point for Huntington-Hill. And this method starts off by finding that same quota, and then we find what we call a lower quota, which I'll put as my header in column C, and that is, we call it N in the formula, is just that same rounded down amount. So we've already got that. That's why I chose to use Jefferson's, because we round it down. That matches with this step in Huntington-Hill. Now is where we deviate quite a bit from Jefferson's method. In column D, we're going to find the geometric mean of the lower quota and one above it. So 5 and 6, 7 and 8, 15 and 16. To do that, we do equals SQRT, and then our inputs is n times n plus 1. That'll be C2 times parentheses C2 plus 1. So there's our n times n plus 1 in parentheses for the square root. I'll accept that and the suggested autofill. Now we see that the geometric mean is pretty close to a 0.5 of each of those numbers, slightly below. And we see that we're closest to a 0.5 at the biggest number, and we're farthest from a 0.5 at the smallest numbers. And that basically means that we don't need to round up with as high of a decimal for some of these numbers. All right, we're going to change our rounding a little bit. And that means that we're going to change this column. We're going to have kind of a lot of downstream changes going on from this point on. I think it would be helpful to start inserting columns here and leave that final portion for later so I don't really mess those things up. All right, so the next thing that I want to insert is going to be an initial allocation, or initial portion is more the wording that I've been calling it. Here's where we're allocating those representatives based on some kind of rule. And it's going to be a rounding rule which utilizes an if-then statement. The rule says if the quota is as large or larger than the geometric mean, we round the quota up. If the quota is smaller than the geometric mean, we round the quota down. I like the second version of that better. So you notice that this if-then statement has one logical expression, and it says spit this out if true, spit this out if false. We don't need to put in both logical expressions. So pick the simpler one. The simpler one says if the quota is smaller than the geometric mean. It's an exclusive inequality. So all I need is just a less than sign. I don't need any equal sign. If the quota is smaller, I'm supposed to round down. So I'll output a round down B2, round down that quota. If not, I'll round up that same quota, B2, and that should be my if-then statement, and I'll fill that down. Now over here, my initial total is not looking at the right thing. The quota will not be used as an initial total. We will use this thing that we just came up with, which is in, I wish this would go away. Oh, here we go. So my initial portion right here we go, column E, 39. Remaining reps is definitely the difference between those two. And so right here is our initial portion is good. We've got everything we need. That final portion, that's not doing what we want it to, so I'm going to clear that out. Now this problem worked great with the very initial proportioning. I'm going to try one that I know doesn't work so great. In this problem, you have 75 representatives for these populations. And we see that we get a lot of these rounding up. All of these except for one, the last one, got rounded up because these quotas are above those geometric means row after row. So we see that it's working as it's intended, but we overshot it. Now is where we'll need this modified divisor and a new total, which we've already got tied to column F. And so we still have the same step 3 with our green color coding that we did before. Let me modify this divisor. Now you have to figure out which way to go. Before, we kept getting remaining reps and we kept dropping down from the initial divisor. But keep in mind, when it's negative, that means we need to bump it up. We need to divide by a bigger number and dole out fewer representatives. So going up to maybe 14,100 could potentially do the job. We see that here's the progression. We went from these quotas to these initial portions. And now one of these needs to drop back down. Let's figure out what we need. Okay, so now we need to divide by our new divisor. Here we go. We're recalculating essentially a whole new quota is what I would call it. So this isn't necessarily going to be our final portion. We got more to do. So we'll do equals A2 divided by the modified divisor. We've definitely done this before. We want a dollar sign in front of that 6 so we don't shade that one down. And now this isn't a final portion. This is an adjusted quota. You could call it a modified quota. We're going to need some more columns here because here's what we need to do. We've got to recalculate our quota and our geometric mean and our portion. We need 3 more columns inserted in here to finish out this process. And what I think would make the most sense is just to copy these 3 columns right here, C, D, and E, paste that into G, and now our new total is actually happening way down here at the end, and this should be a final portion way down here at the end in column I. And I see what changed. It's so subtle. But right here, a 5. No, that was 6. Here's what we had originally. Here's where we're at now. I only see one change, and that's the 45 dropping down to a 44. Because that, here's my initial quota. Here's my new quota. We see it dropped down slightly below that 0.5 mark. So it's very subtle. Now I think I'm at a point where this is all finished and I can paste in different data. We've got a lot going on in the middle. It's completely automatic other than we need to play around with that divisor and obviously update those 2 inputs. But let me go all the way back and try, for example, we've got a problem with 39 representatives. And that one worked initially without any adjustments at all, with my initial portions being correct. And now I can try one more, and I apologize if I already had these in the beginning of the video, but it shows you the little steps that we need to go through to try out new problems. And again, this one worked fine with the initial portioning. I don't need a modified divisor. I've got my answers that I need right there. So it's really rare that we're going to go all the way out here to column I. It's kind of screwing things up with this modified divisor that's way different from what they got. That's why you got these kind of weird numbers over here. But that finishes up Huntington-Hill method and this 4-part series. Thank you for hanging in to the end.